For our lesson for Algebra 2 Honors, we're going to multiply and divide rational expressions. We're also going to simplify expressions that are just given to us when we have a monomial in the denominator. This is page 71 in our Algebra 2 Honors notebook. This is section 7.3, Student Journal 204. I want to tell you to make sure that you factor all binomials and trinomials. That's the first thing you want to do, is factor all binomials and trinomials. Okay, so let's look at number 1. I want to simplify this. I want to reduce it because I have a fraction I want to reduce. But I have a binomial in the numerator. Can I factor that binomial? Yes, there's a common factor of 2x squared. So I'm going to factor out 2x squared. I'm going to keep that 6x squared on the bottom. 2x cubed divided by 2x squared is x. Negative 8x squared divided by 2x squared is minus 4. Then I've got monomial, binomial, monomial. I can only reduce things that belong in the same category. So the only thing I could reduce would be these two monomials. 2x squared and 6x squared. Can I reduce those? Yes. 2/6 reduce to 1/3, which I don't need the 1. X squared and x squared, those would cancel out. And then the only thing left is x minus 4. So I just reduced or simplified this fraction. Do the same thing here. I've got a binomial and a monomial. You don't do anything with monomials, but you do factor your binomials and trinomials. Do not do this. I should have pointed that out. Don't do this. That does not work. So don't do that. Please, please, please. Okay, so my binomial here has a common factor of x, y squared. Numerically, they don't have a common factor, but they both have x to the first power. They both have y to the second power. I would be left with 5y minus 2x. Is that right? 5y minus 2x, yes, over x squared, y squared. Okay, now I have monomial, binomial, monomial. So that binomial is going to remain the same, 5y minus 2x. You can leave it in parentheses if you want. It doesn't matter. And then this monomial and this monomial, I can reduce x and x squared, reduce and leave an x on the bottom. 2 minus 1 is 1. Y squared and y squared do reduce away. So there's my answer. 5y minus 2x divided by x. Now notice, look at number 3. Do not do this. Don't do that. You cannot do that. You have to factor before you can reduce. This term is part of a trinomial. You can't break away parts of trinomials. So we have to factor all binomials and trinomials first. Can I find factors of a times c that will give me a sum of b? And I do expect to see this work right here. So make sure you show it, please. Factors of 4, negative 1 times negative 4 will give me a sum of negative 5. So factor that numerator into x minus 1, x minus 4. Factor my denominator. Can I find factors of a times c that will give me a sum of b? Yes. So I'm going to put x minus 1 times x minus 1. Now I have binomial, 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 binomial. Do I have any that I can reduce away? We're reducing. Yes, I can reduce these two binomials, the full binomial, away. I can reduce that. Are these two binomials the same? No. Then my answer is those two binomials. X minus 4 divided by x minus 1. Moving on to number 4, I have a binomial and I have a trinomial. My binomial has a common factor of x squared. My trinomial, can I find factors of a times c that will give me a sum of b? Yes, negative 8 times positive 3. So x minus 8 times x plus 3. Monomial, binomial, binomial, binomial. I have no other monomial, so I'll keep that monomial in my answer. X plus 3 and x plus 3, I can reduce those away, and x minus 8 is left on the bottom. So I'm going to get rid of this big long line I drew. I don't need it. X squared divided by x minus 8 is the simplified answer. Now, looking at 5 through 8, I have to find the product or quotient. What I would do is just multiply straight across and then reduce the way we've been reducing for number 5. So 3xy times y is 3xy squared. Xy squared times 2x is 2x squared y squared. Notice monomial and monomial. So I can just reduce. Will 3 and 2 reduce? No. X and x squared will reduce. It's bigger on the bottom. It will remain on the bottom. 2 minus 1 is 1. And then y squared and y squared reduce away. So my answer is 3 divided by 2x. Now, when I look at number 6, I have division. I have to rewrite this first. Remember, division is the same thing as multiplying by the reciprocal. So I'm going to change division to multiplication, and I'm going to do the reciprocal of that second fraction. I'm going to rewrite this. I'm not going to multiply. I'm going to rewrite this as y times x plus y. Because remember, you have to have all your binomials factored, and if I distribute y, I'm going to have to undistribute or factor out the greatest common factor. Then this is going to give me 28x squared y. Now, monomial, binomial, monomial. That binomial is going to remain the same up top. Do I have anything to reduce with this monomial with 28? No. Do I have anything to reduce with this monomial with x squared? No. And then y and y squared will reduce and leave a y here. And that's my answer. And remember, you cannot mark these out because monomial, binomial, you cannot reduce those with each other. Okay, so looking at number 7, everything's factored, which is good. I don't want to distribute, and because I did have to undistribute. Division is the same thing as multiplying by the reciprocal. Okay, I want to ask this first. Monomial, binomial, binomial. Can you reduce here? No. Binomial, 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 binomial. Do you have any binomials that can be reduced away? Yes. Okay, so I have to multiply these. X times x plus 1 times x minus 9. And then I have to multiply these. X minus 2 times x minus 1. Now check one more time to see if you can reduce. Monomial, binomial, 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 binomial. Can you reduce these two binomials? No. This is an addition sign. This is a subtraction sign. Can you reduce these? No. So this is the answer. Now looking at number 8, I need to factor first. I need to factor all 4 of these trinomials. A times C, sum of B. -3, +1. A times C, -40, sum of B. -8, +5, yes. A times C, sum of B. +9, -1, yes. A times C, sum of B. +9, -8. Okay, so I'm going to go ahead and factor those. X minus 3, x plus 1. Factor that one, x minus 8, x plus 5. Hope you all are okay with this next thing I'm going to do. I'm going to change divide to multiply. This factorization is going to go on the top, so x plus 9 times x minus 8 is going to go on the top. And then this factorization will go on the bottom, x plus 9, x minus 1. Okay, can I reduce any binomials away here? No. Can I reduce any away here? Yes, x plus 9. I'm going to put all of these binomials together, this one, and this one. this one, and this one. And now I have all binomials. Do I have any I can reduce away? Yes. So my final answer is x minus 3 times x plus 1 times x plus 5 times x minus 1. Okay, moving on to number 9. I see I need to factor all of those except x plus 7. I can't factor x plus 7. I can factor this into x times x minus 2. There's a common factor. Keep my x plus 7. This factors into binomial, trinomial. Use SOAP, same, opposite, always plus. Cube root, square, square. Multiply those two. And then common factor, x times x squared minus 4, which will factor into, I hope you all don't care, I'm going to go ahead and write that as x plus 2 times x minus 2. I can write that up here, x times x squared minus 4. That's a difference of squares, so I factored it into that. Okay, is there anything I can reduce? Can I reduce here? No. Can I reduce here? Yes. This and this will reduce. Now I'm going to write monomial, binomial, trinomial. And monomial, binomial, trinomial. And it doesn't matter what order you write them in. I just like to put the monomials first. Now, can I reduce anything away? Yes, the monomials will go away. These two binomials will go away. And my answer will be the trinomial and the binomial. Okay, moving on to number 10. I am going to factor a times c, sum of b, positive 5, negative 3. Yes. A times c, sum of b, positive 8, negative 8, positive 5. A times c, is that the same problem? No, it's close. A times c, positive 9, negative 1. A times c, sum of b, positive 9, negative 8. Okay, so I'm going to factor x plus 5, x minus 3. Factor this into x minus 8, x plus 5. Factor, hold on. Change division to multiplication. I'm going to put this in the denominator, x plus 9, x minus 1. Put this in the numerator, x plus 9, x minus 8. Then I'm going to reduce. Can I reduce anything here? Yes. Can I reduce anything here? Yes. Put two binomials together. Put two binomials together. Can I reduce again? Yes. These will go away. So my answer is x minus 3 divided by x minus 1. Now I want to finish off with this one. I want to show you that this is a division problem. And then I'm going to pause my video. I've got a few seconds left, and I'm going to show you the answer. Why don't you try? Okay, so here is, and again, I didn't mention this earlier. This problem is not on your paper, so flip this paper over, if you will, and do this on Student Journal 203. Just write that in the space that you have. I factored, I reduced, I multiplied by the reciprocal also. I reduced each fraction, then I put it together and reduced, and here's my final answer. Hopefully you got that as well.